There we go. So we have this new bacteria that was discovered, and it has the following components as part of its electron transfer chain. That's what you can see. It has 5 different electron carriers. How would I go about answering part A? How do I figure out in what order these electron carriers exist? Lowest voltage to highest voltage. So what should be the first component of the electron transport chain? The second one, the flavoprotein B. Okay. All right. So flavoprotein B will be the first component of the chain. What should be the second component of the chain? The NAD plus, okay. Okay, what needs to be then the third component of the chain? Cytochrome C. Mm-hmm. Then what comes next?
Iron sulfur.
All right, so that is it in order of low to high, right? So that would be the order of the 5 components. So what is the final thing that you make at the end of your personal regular electron transport chain? What's the final molecule that you make? This was on the quiz. This may be part of the issue. Water, right? Water is the last thing that you make in your electron transport chain. It's really coming from oxygen and hydrogen combining to make the water. So the question is, if we know that the reduction of oxygen to water has a standard potential of 0.815, is this the final electron acceptor for this organism?
It's higher than
So the answer is yes. And so its potential is 0.815, and we said that flavo A is the end, which is 0.77. So since it's an even higher potential, it can accept the electrons. So really that would be the 6th component of this chain. That would go B, NAD+, cytochrome C, Fe, iron, sulfur cluster A, and then oxygen. So now you'll need a calculator. If you don't have one out, you'll need to fish one out because we're going to do some math. How would you go about calculating the possible number of ATPs that could be generated from this electron transport chain, knowing the electron chain, its initial and final potentials, and the Faraday's constant and delta G? How do I? So, right, 2 parts. First, we have to figure out what the overall delta E is, and then convert from E to G. So the first thing we have to do is to determine delta E. Should be E0 prime. If I can write it in a darker color. So for these, right, it's final minus initial, or reductant minus oxidant, or cathode minus anode, whichever way you memorize it the easiest. And so what was the final step of the reaction? the oxygen, right? Then the first step was this flavoprotein B. So what is my overall change in potential from the start of it to the end of it? I haven't actually calculated it, so let's see. Right about there. Okay. It's a positive delta E, so what does that tell you about the directionality of this chain? Should be spontaneous, right? Because it's a positive delta E, which means that we have lined up our components in the right order to get to the end successfully. So the second part is find delta G0 knowing delta E0. So this is the equation. NF E0, delta E0.
Is it negative again?
Oh, yep. There we go. All right, so what does N stand for? Number of electrons. So how many electrons are being transferred in general for each step? 2. Why does the cytochrome C only seem to have 1? It does it twice. It can only do 1 at a time, and it does it twice overall, so it's part of the Q cycle, which we'll go over in a second again. So cytochrome C can only do 1 at a time, but it'll do the whole thing twice. So N should be 2. Bless you. Space on my paper. Okay, so then let's see, -2 times 964. Somewhere in that ballpark. What does that tell me about the spontaneity of this kind of reaction? Spontaneous, right? So it should be, because we definitely said that our E was spontaneous, so our G should also be spontaneous. So then the final part of this question was, if this is how much energy is released from an electron traveling through this chain, how many ATPs can be made if, right, so we divide it. So 1 ATP takes 30.5 kilojoules. So you can either convert back to kilojoules or leave it in joules. Can you make half an ATP? Not really. So, would you round up or round down then? You'd have to round down. So, whatever this organism is, from 2 electrons passing through the chain, so 1 pass, it can make about 7 ATPs. How do we feel about that? Pretty good? See the logic of how we work through that? Good.
Dr. Fairwick, where's
Yeah.
the 30.5 come from?
30.5. Oh, it's in the word problem.
Oh, never mind. Okay.
There it is. I'm not trying to be tricky. It's in the problem. How do you feel about that? Pretty good?
Question like this.
Strong possibility of seeing this again. Yeah. So if you are into taking notes and putting stars by things, I would maybe put a star circle smiley face by this one. It'll be very similar to this, or maybe I just went ahead and printed this page off the final. I don't know. Depends how lazy I was feeling this morning. Oh, and I got donuts. It's not exactly off the exam, but pretty gosh darn close. So everybody should at least get 8 points on the test. Yeah. Oh, I have written the test. It is going to be 1/4 multiple choice. It's only a fourth, and they're only worth 1 point each. Right? Okay, so not terrible. 1/4 identifying or matching. So like being able to, so right on all the other tests, we've either had you like pick out an amino acid or FAD, ATP, NAD+, be able to, I don't want you to draw them because you guys are terrible at drawing. I just want you to be able to identify. Well, you guys draw structures in a way that I'm like, that's probably right, but it's so messy that I can't tell. Yeah. No. There's not more of a chance you would, if I can't read, I have to mark you wrong. So if you just are able to match, guaranteed matching skills. So be able to identify structures. 1/4 is going to be questions of this style where it's kind of math problem solving. So you will need a calculator. And then the last 1/4 is going to be short answers. So I think I have 5 choices, and I haven't decided to pick 3 of 5 or 2 of 5. If I do 2, they're worth more. If I do 3, they're worth less. So I'm probably going to go with 3 to be in your benefit. Amanda. I'm going to say one problem that looks like this. And then I think there's one question I think in the pick 3 of 5 about, I haven't quite decided how to phrase it, but it's going to be something about the electron transport chain.
And then for the cumulative, is it like the major players like citric acid?
Yeah.
glycolysis?
Citric acid cycloglycolysis, hemoglobin.
Do we have to draw them again?
There's no drawing.
Yeah.
Yeah, there's no mechanistic drawing, no. They'll be in either the short essay section or there'll be some multiple choice questions about them. But there will be no structure drawing, mechanism drawings.
So we
To
don't
try
have to
and-
memorize, we don't have to re-memorize glycolysis. It's just what the structures look like, the products.
They may be in the identify and matching, but I'm not going to have you draw them. Yes.
Would it be a good idea to like go over like the old exams, or are you pulling new stuff?
It's a mixture. Like some of the multiple choice questions you will either have had on a previous exam or on a previous quiz. Because there's only so many multiple choice questions I can come up with that are reasonable and not tricky. Also go over the old homework, because that's, I don't know if you've noticed, but that's where I get all my short answer questions, is either from the regular homework or the suggested problems. Hint, hint. Narrow it down, yeah, chapters 1 through 15. So out of the entire textbook, just look in that first half. That should help you out. I mean, I've already picked out all suggested and homework problems, right? So if you just go back to your suggested homework problem worksheet, it's not that many. Yeah. Yeah, you got till, what, Tuesday? Yeah.
I know like we made in chapter 11.
Yep.
We did in chapter 3.
Correct.
So those won't be on there?
Mm-mm.
Okay, and then we like barely brushed up on like,
Lipids and membranes?
yeah, lipid membranes.
Yeah, no, those are just going to be in the context of, right, this electron transport chain. Why is ATP synthase found only in the membrane? What's the difference between a matrix and inner membrane
So, For the
space?
sake of narrowing down, we probably won't see 311 or lipid membrane.
Right. Nothing specifically from those chapters.
But it'll be similar to like what was important on old tests
Mhm.
or important again.
Yeah, because I still find those things important. If I tested you about it before, I still think that stuff's important.
Okay.
I haven't changed my mind about any of it.
Is there gonna be a lot of graphs?
I would say there's always the opportunity to do some graphing. Like either read a graph or sketch me a graph, especially when you're thinking like enzymes, Michaelis-Menten, right? Be able to sketch me something. Either be able to tell me something like this, right? Or maybe I'll do some competitive and non-competitive, right? Those were all graphs that either you had to sketch or identify. Yeah, labeling. Labeling and then be able to tell me which one's competitive, which one's non-competitive, which one's uncompetitive. What would be the difference between those? Jessica.
Is there going to be a heavier emphasis on the stuff that we haven't been tested on?
Yeah, I think points-wise, it's slightly heavier. But I mean, at the same time, right, this is one chapter out of however we covered, 11. So points-wise, it's not going to be heavier, but it may be a question like this that is worth more points as a block rather than like the multiple choice questions or the essays.
Is that the exact question?
It is not the exact
So
question.
we can get that, like, in practice?
Yes, I would say if you did the suggested problems out of chapter 15,
Out of the book?
out of the book. Yep, this one is pretty much out of the book. I changed a few things about it, but so I wanted to calculate delta G. Yeah.
How much longer is it going to be than the regular exam?
So when I write an exam, I plan on the fastest person finishing in half the time, right? So for a regular test, I plan on the person who knows their junk can get out of here in 30 minutes. This, I've planned on a person who knows their stuff, comes in, blazes through it, finishes in about an hour and 15. But you have the full 2 hours. So it's a little bit longer only because it's going to have like one more calculation problem and one more short answer. And depending on how fast you are at matching, that could be real fast or you could be stuck there trying to figure out, well, I'm debating between these two. So that's my exam writing plan. Other questions? Were there questions about the quiz? Yes. I don't have a copy of the quiz with me. So what kind of questions were there? Sure. Oh, yes. Group final. I'm going to point out that in general, your individual quizzes are so much better than your group quizzes. I know. That's what it is. So a group exam is not a good idea because you end up second guessing. Like there's always that one person who's very convinced that's the wrong answer, and you end up going with that person rather than just trusting your gut and go with the right answer. Yeah. All right. So which of the following are integral components of the electron transport chain? Meaning these components do not have any other substitutions available. So out of the choices we have, right, we had 4 different choices. So number 2 is in 3 of the 5 options. Is ATP synthase part of the electron transport chain? No. It is not officially part of the electron transport chain. It is complex 5, which is needed to make ATP, but is not considered part of the electron transport chain because no electrons are transported through it. So complexes 1, 3, 5, or 2, 3, 1, 3, 4, or 2, 3, 4 pass electrons, pump protons. 5 doesn't use any electrons for anything. It's used that proton gradient. So which means we can eliminate A, B, and E as options. So that just leaves us with between C and D. The only difference between C and D is NADH. Is there any other thing in your body that's able to do electron transport? We could use FADH2, that would be fine. You could, in theory, use a QH2, right? There are other things in your body that are able to transport electrons the way this guy does. So that leaves you with the only good answer is D, cytochrome C and succinate dehydrogenase. That was a thought-provoking one.
Because there's nothing that can substitute cytochrome C.
Correct. Yep, nothing else aside from C is an iron-containing protein that contains a heme, so it's a heme protein. Just about everybody got 2. If the transfer of electrons in a tightly coupled mitochondria is inhibited between 3 and 4, what of the following will occur? So, if we stop the electrons from getting to complex 4, what happens at complex 4? What's the final thing that happens at 4? We make water, right? So we've taken our electrons, pumped them out, and made water. Would ATP synthesis increase if I've turned off the pumps? No, that's not possible. Would you make more water from the oxygen if you've turned off complex 4? No. So C is not good on. I've turned off the pumps, but I've not reversed the pumps. So would the proton gradient change? It would just stagnate. So it wouldn't dissipate, it would just stay how it is.
Would they build up even more?
Potentially it would build up some more because 1 and 2 are in theory still working. And then maybe ATP synthase could still work. The question's a little ambivalent about that. Which means the only good answer is that the electron transfer from the NADH would stop because you've turned off the electron transports. All right, so which of the following paths are the good? So, right, I think everyone decided that A and B were the good choices. You can either go 1, 3, 4 or 2, 3, 4. Why is A the better answer? Right, officially complex 2 uses FADH2, and I have it written as NADH. So A is the better answer of the 2. I accepted both. Yep, because complex 2 gets its electrons from FADH2, not NADH, right? Because it's coming from the citric acid cycle and uses FADH2 to do that reaction.
Can complex 2 ever use NADH? Is that how you mark it, right? Sometimes
It could, in theory, use it because it works the same way. Realistically, I don't think it ever would, but if somehow you manage to suck all the FADH2 out of the cycle, it could use NADH. All right, all the oxygen in your body, almost all, goes through the electron transport chain to get to water. Which is an interesting thing, like when you're thinking of all the air you're breathing, most of it is being used to turn into water to keep your body floaty. So it's kind of cool. So breathing is not just great, keep your body liquidated. And then, yeah, net reaction in complex 1, we transfer electrons and we pump protons. We don't do anything with ATP. More clear about that? Okay. I had one person ask to go through the Q cycle. We'll look at that real quick. Okay, so the Q cycle occurs in complex 3. So complex 1 has transferred electrons from NADH to some cytochromes, iron sulfur clusters, pumped some protons. Complex 2 is taking it from FADH2 and sending it through some Qs. So in between, let's see if I have my picture. So in the space in between complex 1 and 3 and 2 is really down here, 2, is these CoQs or ubiquinones. They're floating in between. If they're in the membrane, what does that tell you about their hydrophobicity? They are very hydrophobic. They are only found in the membrane. So that'd be a great multiple choice question if I ever asked that. Ubiquinones are only found in the membrane, which means they're hydrophobic. So we gotta, I haven't written that multiple choice question, but I might write that one now. That's a good question. So These ubiquinones are being converted to QH2 by both complex 1 and complex 2. They're transferring their electrons to make QH2. So what we have to do is we got to convert our QH2s back to Qs so that they can pick up more electrons and head through the membrane. So it occurs in 2 steps. First, we have one QH2 that enters the close proximity to complex 3. It's going to send one electron through an iron-sulfur cluster and a cytochrome C to another cytochrome C. It's going to send the second electron to a cytochrome B that's going to take this Q that it just made and turn it into a hydroquinone. If you're following the arrows, right? This QH2 turns into a Q. This Q floats up to the top and gets back the electron it just transferred.
So it's regenerated.
It's semi-regenerating. It gave away 2 and then takes back 1. So in the second half, another QH2 enters complex 3. Again, sends one proton to the cytochrome C on the inner membrane space side and sends the second electron back to reduce this hydroquinone to a QH2. So in that way, it's passed the electrons from complex either 1 or 2 along this way. Then those electrons can be used to reduce some water. So let's see. 4 electrons pass from 2 QH2s to reduce 2 molecules of cytochrome C. We regenerate 1 QH2. We make 2 Qs and pump 4 protons.
The part that says it's 2 Qs,
Mhm.
where is that?
So we made 1 here and we made 1 here. This one is usually the one that gets semi-reduced again. So I guess net, we only make 1. But I'll leave it as 2. It's easier to see as 2. Okay, other kinds of questions about this? Anything else? Yeah.
Your office hours the same on Monday, if you have any questions?
Yeah, let me think what I'm doing Monday. I am giving the organic exam from 10:30 to 12:30. So I'll be in my office from 8:30 to 10:30. And then I have a thesis defense at 2. So I'll be around from 12:30 to 2-ish, and I should be around 3 to 4:30. So I'll be around, just a little more scattered than normal.
Can you say those hours again?
Sure, 8:30 to 10:30. 1 to 2, 3 to 4:30. I can guarantee I'll be in my office those times. And I always answer questions over email, unless they're not super complicated. I can answer general questions. If they require like equations, it's real tricky to write over email. Anything else? I told my Gen Chem class this too. Don't cry as you're leaving the classroom because it's your last class. I'm a sympathetic crier. And you guys will make me cry, and you'll cry harder, and then it'll be all kinds of mess. So, if you're going to cry about this, your last biochem class potentially ever, wait until you get into the hallway. Yeah? All right.